second session of Moms Returning to Tech. I'm here as your host today, but I'm not the one you're here to see. Sarah has left us to go to Cisco to do an awesome, really cool job that she really deserves over there. So we're waiting on the new Sarah to come back sometime soon, hopefully, whoever that is. Just a reminder of our code of conduct: just be kind, ask questions, be curious, and be open and aware of everybody else in the cohort, and be lovely. But we always do that, so that's no problem. Just a reminder, we are recording these sessions, so people who can't make it to the session and ask for the recording, then we can give it out to them. So the camera's already on, as you already know, and you've got the links. I'll send these back out in the LinkedIn group, and I'll put them in the chat as well. So you have them all again if you need them. And that has things like the Microsoft Learn modules, which you'll be able to do after this session, hopefully on launching your own web app, or anything else Pamela might want to give us if there's anything you want to add. So on to today's session. Today we've got Pamela Fox here, Principal Cloud Advocate, who works with Python at Microsoft. Previously, she was a lecturer at UC Berkeley and is the creator of the programming curriculum for for Khan Academy, which is very, very exciting. So yes, today you'll learn how to deploy a web app to the cloud with GitHub and Azure. This will build on last month's setup, where we covered some of the development basics on basically we got GitHub set up and linked it up to VS Code. So then today we'll be setting up a Python web server, running it from GitHub, and hosting on Azure. Well, that's what we'll talk about. I don't know, Pamela, are we going to be doing it today, or are we going to be learning about it today and doing it at home later?
Really depends how quickly the deploys happen.
Love it. Fabulous. Cool. So they can follow along if they want. But we'll learn about the benefits of cloud computing, what it has to offer, and how to get it set up for your needs, and explore some Python and useful frameworks for getting set up, because there's lots of tools out there that'll do a lot of the stuff for you. So very excited to hear Pamela's talk today. So I'm going to hand it straight over to her so she can get to the good stuff.
All right. Thank you, Renee. So let me go ahead and find that button. All right. Here we go. All right. Okay, so welcome everyone. I am a mom in tech. I have a 3-year-old and a 10-month-old who is getting her 4th tooth today. So she's currently upstairs screaming her head off. I don't know. We just gave her some medicine. But welcome everyone. I do love talking about Python and making web apps. So I'm excited to talk about this today. I did post the link to the slides in the chat, so you're welcome to reference those. This talk is based off a workshop that I've given for another women in tech organization. So it does have some exercises throughout, and I'm going to encourage you to do those exercises as homework. And Renee was saying, like, you can have some more stuff you can work on after. So I left them in the slides so that you could have something that you could, try yourself later. Because we only have an hour. An hour is honestly not a lot of time. It's hard to get something hands-on in an hour. So I'll show you stuff. I'll give you some idea of what you can do when you've got more time on your hands. And if you do end up having questions, you're welcome to ask me. So we'll talk about the web, Python for web apps, Flask, Django, and then how to host on Azure. Lots to talk about, so some stuff I might go more quickly through. In terms of what do you need in order to be able to actually if you wanted to do, use the repos that I'm going to show, and if you wanted to deploy them and run them locally yourself. And I think of there being basically 3 different development environments. One is just using GitHub code spaces. That's what I actually use a lot of the time now, because it's the easiest way to get started. It's all in the browser, so you just need that GitHub account. Two, if you want to do local development with VS Code, if you do want to use VS Code locally, then I also recommend having Docker Desktop and the Deb Containers extension, just because it'll give you a nice environment for the repos that I use. Or the third option is, just whatever you want to do locally. If you got an editor, you've got Python 3, it should be possible to use that setup as well. But GitHub Codespaces is generally going to be the easiest way to get started with all these. So very quickly about how the web works, just making sure that we're all, have the same terminology as we're talking about, how do we make web apps? What are servers? So we've got clients, we've got servers. Clients are the browsers, the phones, whatever's browsing the web. And the servers are the actual computers that are, in the, connected in the cloud somewhere, which means like in a data center somewhere, and that are responding to requests from clients. So clients use the HTTP protocol. That's Hypertext Transfer Protocol. They use this protocol in order to make requests to a server, and the server sends back HTTP responses. That is how the web works, is over HTTP. This is what HTTP actually looks like. So it starts off with a verb. The most standard verb is get. So when you load a web page, you're actually doing a get to get that web page. And so you tell the server what web page you're trying to get. You say what path you're trying to get and what domain you're looking on. And then the server will respond back, hopefully with the content if it found it. So if it found it, then you're going to get back and at a status code of 200. So 200 means success. And then you'll also get back some headers that describe the content, and then you'll get back the content itself. Now, if it wasn't successful, you can get back a different status code. There's quite a few status codes out there. My favorite ways to browse the status codes is htpcats.com. You can find your favorite cat here, but these show you all the codes and cats that represent them. The most commonly other one is 404, which is, when it doesn't find the path. And then, typically these responses are web pages, and web pages are usually made up of HTML, CSS, and JavaScript. We're not really going to be talking about those here, but I do love those languages as well, because that's what enables me to make web pages. So why do you need a server? Well, you can have a really basic server, and a really basic server is basically what we call like a static server or file server, which would just serve up HTML pages and CSS and JavaScript files as if, it's from a file system. And that can work okay for really small websites. But once you start getting to bigger websites, you're going to want a server so that you can do things like reusing content across HTML pages, using templating, being able to have a much nicer reusable code base. And also, if you want to be able to access a database, you're going to want a server to do that. The server is going to actually be the one liaising with the database. And then if you're going to have any sort of user login, you certainly want a server for that so that you can deal with like setting user cookies on the server-side code. It's going to be much more secure. So that's the sort of stuff we use a server for. Okay, so how do we do server-side Python? And if at any point you do have questions, please do post them in the chat. I am going to go kind of quick through this because we have such limited time, but I am also happy to answer questions. So how do you write a server in Python? There is a module in the Python standard library called HTTP, and it does have a server class in it that you can use. However, there's a big old warning on here that says http.server is not recommended for production because it only has basic security checks. The web is a very insecure place, so you really don't want to be using this for production. However, it can be useful when you're developing stuff locally. So I'm actually using it right now for my slides. So my slides are actually an HTML page. And so I am running a server using, let me just run it again. So using this module, let me make it a lot bigger than that. So I say python-m hp.server, and that when you run that command, by the default action is to serve a static file server from the current folder. And then I can go and open that in the browser and see see all the slides that I'm working on. And so then I make changes and I can reload and see what I'm working on. So that local server is a great thing to use when you just need a quick server for local development. Totally cool to use it then. And you can specify different ports here, whatever you need to do. But it's not good for production. So what do we do for production? So for production, we're going to want a production level server and also a production level framework. And there's actually a difference between production level servers and production level web frameworks. And we might see that soon. Maybe there's a lot to talk about here, but Flask is a very popular framework for handling server requests and responses. It's used by a huge number of apps. So I used it when I was at Khan Academy, because Khan Academy was originally written in Flask. Reddit, I think, is still written in Flask. Netflix, still written in Flask. So it is used by millions of websites, very popular. Let's look at a very simple Flask website. So this is one that you could open in Codespaces and try for yourself if you wanted. So let me think. I have a Codespace open right here. All right, so if you did want to open in Codespaces, let me show you what that looks like. You go to the repo. Oh, so let's see. Janani says, can't she see the screen? My screen is still shared, right?
Yeah, I can see your screen, Pamela.
Yeah, okay.
Maybe you need to go out and come back in, Janani.
All right.
Can the other two see it? You'll definitely want to be able to see it.
Absolutely. Well, that's where a lot of the good stuff is.
Yeah, now I can see it. Yep.
Yay.
Okay, great. Whew. All right. Very good. So if you want to open something in Codespaces, you go to the repo, you click on the code tab, and then what you'll see is a big green button here. I don't see it right now because I already made a Codespace, but you'll see a big green button that says create Codespace on main. So then you'll click that and it'll create a Codespace. It does take a few minutes to start up a Codespace. That's the worst part about Codespace is that it does take time to set it up. But then once it's set up, everything should just work. And that's what's really great about Codespaces, because one of the annoying things about development, software development, web development, is that sometimes it can be hard to get all the dependencies set up on your local system correctly. So that's why I like to use Codespaces. So here I'm actually inside this repo, and I have a very simple Flask server here. So in order to make a Flask server, make a Flask app, I have to use the Flask package. It's an external package, so I put it in requirements.txt, and then I install from requirements.txt using pip. So I can do pip install-r requirements.txt, and that brings in Flask and all of its dependencies. And then I have app.py, which actually creates the Flask app. So we import some stuff from Flask, we construct a new Flask app, and we tell it where to find templates and where to find static assets. So we'll see those in use soon. And then we define our routes. So the routes correspond to functions that handle each route. And so these routes are paths, right? So / is the main route. So that's what you're going to reach when you just go to the domain with nothing after it. And this is going to return a render of the template index.html. So let's take a look at that template here. And you can see this is just an HTML page. There's nothing different about this from normal HTML. So we can do that. We can just return a normal HTML page. That's not very exciting. So let's move on to the next route, /hello. This one renders a hello.html and passes in a template variable. So now you can see how we can start to customize templates based off of information. And a lot of times that information comes from a database. In this case, it's going to come from the query parameter, but many times it's going to come from a database, and then you pipe it into the template. So if we look at hello.html, we can see it actually has some template language here. This is the Jinja templating language. So it says if the name variable exists, we're going to say hello to that name. Otherwise, we're going to say this. So this is a mix of Jinja and just standard HTML. right? So these parts are Jinja, and then the rest is HTML. So let's actually run this app so you can see that in action. So to run it, I'm going to use the Flask module. So Python 3-m Flask run. I'm going to give it a port. I'm going to put it in debug mode. All right, so it says it's running. So here we go. That was a weird run. I'm going to try that one again. Claiming not found. It's code space being a little funky there. Let me try a different one. Just gonna shut that one down, try it again. There we go. I love code spaces, but they do sometimes do weird things, which is why I have the code space engineers on speed dial. I've been pinging them a lot this week. So here, that's the main site, but we're gonna go to hello, and I'm gonna type name equals Pamela. And here we see it says hello, Pamela. So this is an example of a dynamic web page, right? It's results are different based off of some sort of input. And that's the sort of thing you can do with a server that you can't do with a static app. All right, and we can also do like error handlers and stuff like that. But this is, this is the basics of a server with templating. And many server frameworks are going to have a very similar approach with how you define routes, how you get query parameters, how you pass things into templates, that sort of thing. So here's an exercise you can try later to see if you can do a little Flask templating. Okay, any questions on that before we move on to databases? Okay. All right, so a lot of web apps store data in databases. Super helpful to do, and I know some folks here are coming from data science, so you know the importance of data. So many web apps have some sort of data, like either they have data because they're a content website, like a news website, and their data is the news that they're serving up each day, or they have data because they're a user-facing website, like a social media site or a productivity site, and they're storing the user data. Either way, they have data. They need a way to interact with a database. And a database actually usually lives kind of outside of the web app. So then the web app needs to communicate with the database in some way. So let's take a look at how we do that in Flask. First, I'll show you what we're making. This is a Flask quiz. You can try it out. So I'll put my name. And here we have who invented Python. It was Guido. What was Python named after? It was named after the comedy group. When was the first version of Python released? I think 91. I always get that one wrong. And what was released? It was 3.11. It's an awesome version. It's really fast. So I'm going to submit my score, and woohoo, I got 100. And looks like a lot of other people got 100 too, but I can see my score in the high scores list. So this high scores list, this is what's stored in the database. The only way that I can have a high scored list with a web app is if I have some sort of database, because this is central data, right? Anyone visiting my website from anywhere over the world should be able to see this high scores list. And that means I need to have a database to store it. So how do we actually do that? So let me open up the code space for that. I think it's over here. Yeah, it's over here. All right. So connecting to a database is actually it's a lot trickier. There's a lot more code involved in terms of a database. One is that you have to figure out what kind of database you're going to use. This one actually uses SQLite locally and then uses PostgreSQL in production. So there's many different kinds of databases. There's both non-relational databases, there's relational databases. I tend to use relational databases this day, which is typically SQL. So with SQL, there's MySQL, there's Postgres, there's SQLite, there's Maria. There's so many different SQLs. One of those I don't know if Maria is a SQL, but there are a bunch of different varieties of SQL. so yeah, so this one is connecting, this one's going to connect to a SQL database. And in Flask, the way to do that is to use the SQL Alchemy package. And also, I also use, so let's see, I use SQL Alchemy, I use Flask SQL Alchemy, which kind of connects the two. I use Flask Migrate, which helps as well. I use PsychoPG, which is specific for Postgres. And then I use python.env in order to read environment variables in. So you notice like the jump to databases meant we had to add a lot of stuff to this Flask app. So yeah, so we had to bring all that stuff in. Then we need to do this, you know, we need to connect to the database. So there's a way we can construct a database URI that connects to the database. And then we define models for the database. So this is one way we can define models with SQL Alchemy. So this is our player score model. That's the only one we're going to have in this app. And each row will have an ID, a player, and that's just the name that I entered on the site, and a score, which is the integer, which is, you know, how many they got right. So that will be the only table in our database. Okay, so then I can set up the routes. And so then we have all these routes, you know, for dealing with this data. So you do see a route here that actually creates a new player score model and inserts it into the database. And that's using a post. So whenever I click that form, it does an HTTP post and sends along the data about, you know, what I entered in the form and what my score was. And then that gets handled here. And then here we have this /scores, which is a get, and this one executes a query on the database to get all the scores and sorts them. And then it returns back JSON, JavaScript object notation. It returns back JSON that has those results. And the web page continually calls this in order to get the data that it displays at the bottom. So there's a whole lot more going on here. But let's try running this locally. And we'll just check the README to make sure we're using the right command. All right, and then we'll open that up. Okay, so there you can see it's running locally. Boop. Oh, and it does actually have an error. No such table, player scores. That's right. I actually should have done a migration first. So let's see, to do the migration, should be a DB migrate. Let me see, target database is not up to date. Maybe we need to do upgrade. I always forget the commands here. Okay, and then let's try migrate. And that might have done it. Let's see. Oh, we need to run the thing again. Yeah, so we both need to define the models in code, but then we also need to tell our database what tables it should have. So that's what migration is for. So migrating means, yeah, so this time it did actually work. So let's actually fill it out. Okay, so it says I got 50%. Is it going to, I see the select here. Should show up. It may not be possible that the database isn't perfectly configured for local development. So this interesting is once you work with databases, you have to have a local database configured, and then you have to have a production database configured. So this one, I definitely have it configured correctly for my production database, but maybe the local database isn't perfectly configured. So I'll have to check that out. But yeah, the production one works, so that's good. Let's see. Okay. Yeah, because this is our production one here. This one is on Azure. So I deployed this one to Azure with a Postgres backend. Okay, so that is Flask. Now, you know, Flask is a little bit tricky to bring databases into because Flask is what's considered a not opinionated, like a lightweight framework. So a not very opinionated framework. So it doesn't, by default, it doesn't know how to work with databases. You have to bring in all these packages when you want to work with databases, and that can get a little bit hairy, like we saw here. If you want to work with databases, what I typically recommend is actually using Django. So Django is another third-party package that is a very opinionated framework for server-side web apps, and it includes an ORM for database interaction. So it includes something like SQL Alchemy. It always has that because it assumes that you're going to want to work with a database. So I find it's much easier to get started doing database stuff with Django because that's what it's designed for. So if you feel like you're making a fairly typical application that has a database in it, especially if you're making like a content site, because Django was originally written for a news website. So especially if you're making some sort of content site, Django is really good for that. And there's even, specific kind of variants of Django like Wagtail, which is a CMS built on top of Django that you could use as well. So many apps are written in Django. Coursera was really written at Django when I worked at Coursera. Instagram, Pinterest was originally in Django and then moved to Flask. Eventbrite, very popular and a great community too. So let's take a look at a Django quiz now. Oh, that's actually restaurants. Okay, well, we can look at that one too. Forgot where's the URL for my Django quiz. Well, actually, that one is a better one to look at. Okay, let's take a look at the Django restaurants code instead. It's a little more straightforward. Okay, so I'm actually going to look at this one. Yeah. And here you can see it running. So this is the Django site. It's for adding restaurants and reviews. All right, so we can go like this, my awesome restaurant. And then you could add a new review. So good. Woo! All right, and then that's all being added to this site. So I'm gonna go ahead and open the code space. So this is what it looks like if you're trying to create a code space, is you see this big button. And so I'll click on that, and that will take a few minutes because it hasn't created it yet. So it needs to build this whole environment. But we can take a look at the files while that's loading. So in a Django site, like first let's look at the requirements. So here it's actually less requirements than in the Flask site because Django has so much of this included. So we do have Django, then we have psychopg again. That's because we're using Postgres specifically. We have python.env again because we're using .env files for our environment variables. And then we have white noise, which is just a way of dealing with static assets on production. So those are our requirements. And then we can look inside restaurant review for everything that has to do with the restaurant functionality we see. So generally in Django, you'll find every folder has urls.py, views.py, and models.py, hopefully test.py if you're testing your code, and sometimes admin.py. So let's start with urls.py. So if we look at this, you can see that the URLs define the routes and what handles them. So these are always put in a separate file just for good organization's sake. So here we can see these are all the routes on this website. So we can go to the index, we can see the details for a particular restaurant, we can create a new restaurant, and we can submit the form for that, and then we can also add a review. Then we have the views.py, and that is what has the functions that were mentioned in the other file. And so we have index, details, create restaurant, right? And so these all interact with the database. So you can see that index does a query of all the restaurants in the database and also asks to get their review rating back so that it can show the number of stars on the page. And then passes that to the template as template variables. So what you notice here is that Django also has a templating system. It's not exactly the same as the Flask templating system, but it's very similar. You specify a file name and you pass in some template variables, and it's going to combine them together. And yet the other views are similar, and some of them also are doing handling form data. So they're looking at the form data and then creating new objects in a database. So here we create a new restaurant, we save the restaurant. So those models are all coming from models.py. And remember, every Django thing has this follows the same structure. So Django repos, Django projects tend to be more straightforward to follow than Flask ones because they should follow this standard form. So here you can see our models, and we define them similarly to the Flask one. Then we can have some tests. Oh, look, I wrote tests. Yay, go me. And then we also have this admin file. And that's because Django comes built in with this admin interface so that you can create new objects in your database really easily. And it is so cool. So I love the Django admin. When I was at Coursera, I spent a lot of time working on our Django admin. But it's just really nice to have a easy to use user interface for interacting with your database so that you're not just doing like raw SQL queries. Okay, oh, let's see if okay, so this is open now. All right, and so let's see if we can run this one. So this one does say, all right, so first we're going to install the requirements. And yeah, if you remember, if you do have any questions, feel free to ask or put in the chat. Okay, install the requirements. We need to create the .m file. So I'm going to take this .m.sample and just make a new one based off of it. Oh, I'm just going to do it based off this one. So this has everything that we need for code spaces. Because in this code space, I actually have a Postgres server running. This is something I love about code spaces, is that I can run Postgres servers inside it. So you can actually see 5432, that's actually a Postgres server that's running. So I should be able to connect to that Postgres server from my app, all inside this code space. It's really cool. Okay, so now I need to run the migration. So running the migrations is going to look at our models and apply those changes to whatever database it's connected to. So this is how we'll find out if our database connection actually worked. Okay, it did work. So we can see it applied a bunch of migrations. So this includes all the default Django stuff. So Django adds a bunch of tables for its own purposes for admin and auth. And then it also added our tables, restaurant and restaurant review. And then finally, we should be able to run server. Okay, let's open this up. A server error. Oh, the secret key setting must not be empty. Oh, because I skipped a step. Silly me. Should not have skipped that. Always read the README, especially when you wrote it yourself. Okay. Here we go. Okay, so this is running basically locally from Codespaces. So now I can add stuff to it, and this is all just in the local Postgres database. And I actually have this Viscode extension, SQL Tools, which lets me explore the local database so that you can actually see what's in it. So you see all the default Django tables, and then we also see the ones we added. So I can take a look at restaurant review, right? And we can see this amazing, amazing restaurant I just added. So that's cool. That is all stuff you can do locally with Viscode. And here's an exercise that you could do later is to try and get it running yourself. Also try to get the Django admin running and add some stuff, and then also add a route. Okay, any questions on Django? The next thing we're going to talk about is hosting. All right. Okay, let's talk about Azure. So how do we host these? Okay, so what are our hosting options, right? So hosting means putting it on some server where it's going to be always available, right? Like in some ways, it almost looks like my app is hosted right now because I have this URL for it from Codespaces, but this is a temporary URL that's only for me to develop, use when I'm in Codespaces. I want a fairly permanent URL, or as permanent as I want it to be, where anybody from all over the world can hit it up at all times. So, you have a lot of options for that. You could actually turn your home computer into a server, but most people don't want to, manage their own server. Most people will rent somebody else's server in a data center somewhere. Or even rent just a part of a server. That's the cool thing that we can do these days is slice up servers so that if your app doesn't require that many resources, it can be served along with other apps on the same server, and that's better for the environment is to not waste resources. So Azure tries to optimize use of its hardware so that it's not wasting resources and not using electricity on things that aren't actually doing anything. So things to consider is, how much control do you want over your, over the thing you're hosting? How much do you like administering systems? And how much scale do you need? Do you need it to scale up, like to be able to handle lots and lots of traffic at once? Do you need to be able to handle lots of traffic over a long period of time? What kind of traffic are you expecting? So Azure has a ton of hosting options. This is actually only a fraction of them, but these are the big ones that we usually talk about. So, on top of Azure, we've got what you might call platform as a service options. And these ones are ones that do more for you, like they manage more of the experience for you. So Azure App Service is, I would say, the classic platform as a service option. And that's kind of my default, my go-to. And that's what I would recommend for getting started. And that's what I'll deploy here. There's also Azure Functions. This is what's also known as serverless. It's like AWS Lambda or Google Functions, if you've heard of those. And, that's if you have really, really quick things that like quick APIs that you want to run, and not usually for like full-on websites. So if you're making a standard website, you're probably going to be doing app service. We also have container options. So these are if you really like working with Docker and containerizing your application, this is what you're going to want to look at. So there's Azure Kubernetes service, which is Kubernetes, but managed by Azure. And that's if you enjoy managing Kubernetes. I actually have never managed a Kubernetes service, so I have never used that myself. And I don't really want to. I'm not really a sysops person. But Azure Container Apps actually does some of that management for you, but is basically Kubernetes behind the scenes. So I have actually used Container Apps. I used it for my personal website for about 6 months, and it was fine. I put it behind a CDN. But yeah, it was pretty easy to use. So the two ones that I use the most often right now are Container Apps and App Service. Okay, Janani has a question. What does the term container refer to? Good question. It refers to Docker containers. And there's a big trend these days to Dockerize things or containerize things, and it makes it easier to make an isolated environment for your app so that it has everything inside there. And if you think about it like shipping containers, once they came up with that standard size shipping container, it became easy to ship anything. That's the idea of Docker containers, is that it's a standard way of packaging, bundling everything up so that you can run it anywhere. And that works really well for the cloud because you just say, oh, here's my container. I'm going to send it to you and it's just going to work, right? So you make it once and it'll work on any machine. That's the goal. That's the dream. That's the point of containers. I do also have a containerization workshop, so you're welcome to look through those slides later too. And that's containerizing Flask.
All right. Pamela, before you move on, one other question, I'm sorry. So can you also give me an overview of what this Kubernetes is?
Yeah, so Kubernetes that's a great question because since I haven't used it, but I've heard of it quite a bit. So Kubernetes is a way, it's I think what we'd call container orchestration. So there is that you have lots and lots of containers. So you'll have like one container that has your web app, another container that has your search service, another container that has your mobile backend API, another container has your machine learning processing, right? So you'd have a bunch of containers that are running different facets of your application and all communicating with each other, but they might all have different scale needs, right? So maybe you need a lot of scale for your search service, but not so much scale for your mobile backend or something like that, right? So with Kubernetes, you would be orchestrating these containers and saying like, okay, like this, I'm going to have, be scaling up this, all these containers over here and these ones over here, and, using some sort of configuration in order to determine the parameters of all those containers and how they're going to be scaling, how they're going to be load balancing, all of that.
All right, thank you.
Yeah, great question. I need to learn more about Kubernetes myself soon, hopefully in the next year. I do want to learn it, but there's so much to learn in this world.
We'll be doing some Kubernetes next month with George. So
nice.
I think he's doing containerization and he's a Kubernetes expert. So I have to expect it's going to come up, Kubernetes.
Okay. Oh, beautiful. Beautiful. Perfect. That's a really good follow on from this one, actually. So yeah, I would say for Flask and Django, App Service is the easiest way to get started. App Service actually knows about Flask Django. There's literally code in the App Service code base that recognizes when you have a Flask app and recognizes when you have a Django app and acts accordingly. So it's well suited for Flask and Django. But you probably also want to add other things onto your app. So not just using App Service, but maybe you want a CDN in front. That's a content delivery network. That's if you want to do caching. Maybe you need a key vault to store some secrets, like to store your database secret. The database, of course, you may want to, actually have a database, and that's going to be another managed Azure service. So a lot of times when you are deploying to Azure, you're not just using one service. Most of the time, you're using multiple services, and you're mishmashing them together. And that's something that I didn't really realize at first because I wasn't used to that way of, of cloud computing, but that is the way it is these days. Because there are so many different services, and that way you can pick and choose, and then the pricing is going to be based off of which ones you decided to go with, and you can use more or less depending on your needs. So for App Service and Postgres, there's a few different kind of architectures you can imagine. So one architecture would just be App Service with the Postgres database, and also with, you'll always have, whenever you have App Service, you're also going to have an App Service plan. They just come together. The plan does some of like the scaling stuff. And then I usually throw in a log analytics workspace. It's really cheap, basically free. And that's just if I want to do some advanced logging and analytics. I just always good to throw that in there. But the heart of this is App Service, and they communicate over, to each other. So how do I actually do that deployment? There's many different ways of deploying to Azure. The way I like to do it is to use AZD up. So let me see. So we have 12 minutes. I think I might be able to get it deployed in 12 minutes. Let's find out. So let's get this open. Close all these ones. Restart code base. But all these repos have instructions about how to deploy with the Azure Developer CLI. So this CLI uses a language, Bicep, in order to define what's going to get deployed. Bicep is known as an infrastructure as code language. It's like Terraform, if you've heard of Terraform. If you haven't, no worries. But it defines all the things that we're going to deploy. And it's all in the infra folder. So if you want to see what's going to get deployed, we look at main.bicep, and it says like, okay, it's going to deploy a Postgres flexible server. And here's like the size of it. It's going to deploy app service. And here's some configuration. It's going to be like Python 3.11. It's a startup command. Here's all our database connection variables. And then there's their app service plan and some key vault stuff to store the database secrets. And there we go. So this is Bicep file. This is infrastructure as code. This is one way to deploy to Azure. I really like using infrastructure as code. Not everyone likes it, but I like it because it's repeatable. So once I've defined my infrastructure as code, the idea is that I should be able to, it should always work. We'll find out if that's true, right? So let's see, I'll do AZD off login. All right, so I need to go, and I'm going to do it in my personal account. I'll just have to remember to delete it afterwards so I don't incur any cost. Because some of these things do cost money, depending on your account and whether you currently have the free account. the pricing is kind of complicated, but if you have the free account, then they won't cost money. Okay, so now I'm logged in, and then I can do AZD up, and I'm going to give it a name, and this just becomes the name in my portal. So Django Q, select an Azure subscription to use. Okay, select a location. I'm going to go for Central US. Hopefully that's a good one. Sometimes things aren't available in some locations. It just depends on data center capacity, right? Because Azure doesn't want to have too much capacity, but also doesn't want to have too little, and it's always a balancing act there. So what it's doing now is that it is taking a look at all those bicep files and figuring out what resources it needs to create in the portal. So the first thing it does is make a resource group, and that's the actual folder that's going to contain all the resources. And now next up it created the app service plan, created the log analytics workspace. It's still got a few more things to create. Okay, it's made the key vault. And I can also watch this deployment in the portal. So let me go to the portal here. Yeah, you could also use there's like 5 different ways you could use the portal. You could use the Azure CLI, which is different from this CLI. This is the AZD CLI. You could use the Viz Code extension. Some people love the Viz Code extension. For me, it's like just when it starts to get too complicated, like if it's just one thing, like if you're just deploying to one resource, then I think like the Viz Code extension is pretty good. But with the amount of resources I'm creating, I like to use Bicep. But I'm also the Bicep fangirl in my group, so it might just be me. So yeah, you can see these. Yeah. What? Oh, the cool kids.
I was gonna say all the cool kids are doing Bicep.
Yeah. And you know what? The portal is basically doing IAC behind the scenes. I'm pretty sure. I think it's using an ARM template. So originally there was ARM, and then they made Bicep, which is a stronger version of ARM, right? And I believe the portal uses an ARM template. Maybe. I think.
I have no idea, but I love that's where the name Bicep came from. It makes so much sense now.
Yeah. So you see the deployments happening. And the cool thing is with the Bicep files, it actually looks to see what things it can do in parallel. So it actually makes a dependency graph and figures out like, oh, this is dependent on this, so we have to do them in a certain order. But if they don't have dependencies, it can actually it can do them in parallel. It can make these things in parallel. So that's another advantage of using Bicep or ARM, is that your creation of all these resources can be faster. And this is only going to be really slow the first time, right? This is a brand new, I'm creating a brand new resource group. All of this is brand new. So Azure is carving out these, services for me. The next time, if all I've done is modify the code, then it should be really, really easy for me to deploy, because it doesn't have to recreate this stuff. It'll basically look and say like, oh, I've already made all this stuff. All the configuration's the same. I'll just deploy the code this time. But the first time it is going to take some time, especially with the Postgres server. That's a fairly new service, and it does take some time to that's the slowest one of this particular batch. It takes some time to make it. Hopefully it's available in this location. Sometimes there are location constraints for that server. If it's not available in Central US, then I'll try East US instead. But let me see if I have a prepackaged version I can show you. I probably do. Like on the cooking shows. Okay, let's see, Django quiz. Okay, here we go. All right. So this is one that I deployed before on my corporate account. And you can see it's got the app service plan, the analytics, Postgres, and Key Vault. So we can explore any of these. So we could go to app service and we can see the endpoint, the URL to access that site at. If there are any problems with it, I can go into the log stream and I could check the logs. I could also use the log analytics workspace to look at logs. I could change, I could look at configuration. I try to only change configuration in Bicep, but I could look at the configuration here and see what it's like. Yeah. Here's one I prepared earlier that's still loading. Let's see how this one going. Yeah, still. Oh, it did finish the Postgres. Okay. So after AZD has created all those resources, the next step is to actually deploy the code. So the code is not deployed yet. All that's happened so far is that the resources are created, but it does need to deploy the code, which means actually taking all the code and bundling it up, zipping it up and uploading it to Azure servers. So it knows what to bundle because of this azure.yaml file I have, which says it's going to bundle up the source folder and deploy it to App Service. And so that's what it's doing right now, is actually deploying that package up. And that takes some time too, because it's doing the logs. So let's see this one. Oh yeah, this one actually, I need to work on I changed my password. I need to update my configuration there. I made too many changes to this. Do I have another one? No, I deleted it. I do so many deploys every day, I'm sorry. So this one did deploy in my personal account. Okay, so we're just waiting for the actual code to get deployed to it. Okay, all right, so we'll wait for that. What I'm going to talk about while we're waiting for that to go is another architecture. So the one that I'm deploying right now, it communicates using admin username and password to Postgres, and then the networking configuration. Let me show you the networking configuration that I've used on the Postgres server. This is something really important that you have to figure out with your databases, is how you're going to protect them, how you're going to secure them. And of course, security is really important to us at Microsoft, hopefully everyone. So taking a look at the Postgres server here and looking at the networking, what you see is that it says this one has public access, which is a certain like allowed IP addresses. And what I've allowed is public access from any service within Azure to this server. So that means anything running on Azure, including other customers on Azure, can connect to the server. But they also need the admin username and password. So I picked a very, random username and password and stored them in Key Vault, and I'm connecting with that. So that is the mechanism I'm using. This is not the most secure method. The most secure thing is to use a virtual network so that the only thing that can connect to your server is your app service. So that is the recommended approach. It does cost a little bit more and does require making a few more resources. So not everyone does it, depending on, if your app actually has like secure data in it. Most data is, but you never know. Maybe it's just like a dog spotting app. But if you want to put it inside a VNet, this is what it looks like, right? Your app service and your Postgres are both going to live inside the same virtual network, and then they'll use a private DNS zone in order to communicate with each other. And you can still expose the app service to the world, but you don't have to expose the Postgres to the world. And that is our recommendation. That's what our official sample uses. So if you want to find a sample that has the infrastructure for that, then go to one of this one. There's a Django one, there's also a Flask one, and there's also a tutorial that correspond to it. But you can once again use the AZD CLI in order to deploy all these resources. So it is a more complicated setup, but ideally you can just write AZD up and it will all go up. Let's see how we're doing over here. Still deploying. So we may not be able to deploy in time since we only have a minute left. But I do encourage you to try using AZD on these repos. One thing that's important is that after you do get something up, afterwards run AZD down for two reasons. Like one, just generally we don't want to waste cloud resources, and two, we don't want to accidentally have you incur any costs. Like we try to use as close to the free level as we can for these sample repos, but not everything has a free level, and it also depends on whether you're like in your first free 12 months of a Azure account. So best practice is if you're not using it, always run AZD down, or just go to the portal and delete the resource group. I do that like every day. Just, don't want to have anything running in the cloud that you don't want to have running in the cloud. Here are a bunch of more Azure resources specific to Python and Azure. And so these are tutorials we recommend for getting started. This one has a whole bunch of links about different ways you can run on Azure, including functions and container and Kubernetes and all that. And yeah, there we go. Let's see, still deploying. We didn't make it. So it can take some time the first time. So it's 6 o'clock now. Are there any questions?
No questions, Pamela. Thank you so much.
You're welcome.
Here's no questions. I'll just pop up the slide about next month's session, so you all know what's coming up. And yeah, I'll make sure that we put all the links out in the LinkedIn group as well. But they're all in the slides, which are all just online as well, which I think you might have linked up earlier. I'll link to this whole slide deck, Pamela. Fabulous. Yep. Okay, cool. Well, I just have the one slide for what's coming up next month. Next month we'll be joined by George, who's talking about teamwork and testing and how containerization and CI/CD, which is continuous integration and continuous deployment, simplify the dev cycle. So basically talking about a lot of the kind of infrastructure-y stuff Pamela just talked us through, and how it can get automated, how tests can get run automatically, and how containers help us develop easier because it's kind of running on the same environment that it is running on in the cloud. So we're going to talk about how all those ways of working and ways of working together help us work better as a team, and how we can use tools like GitHub and I'm assuming the Kubernetes, Azure Kubernetes service is going to come up as well, knowing George. So yeah, that's what we're going to be talking about next month. So yeah, make sure you're registered for that one. I'll just drop all of the links in the chat as well. But while I do that, thank you so much, Pamela, for coming along. I learned a couple of things myself, which was really great. So yeah, this was delightful. And yeah, everyone, yeah, if you want to give Pamela a little round of applause, I'll be doing that myself because I love the reacts. But yeah, thanks so much. And yeah, last chance for any questions from Pamela, I think, before we all run away.
Just wanted to thank her so much for answering everything patiently.
Yeah, great questions, everyone.
Amazing. Cool. Well, we'll see you all next month. Tell your other mum friends if you have more mum friends in the group, so we can have more people here. But yeah, also have the recording if you want to watch Pamela again, because it was very good and so fast paced to get through so many different things. Sadly, we couldn't get that last deploy in. I know the struggles of. Please just deploy
it did just deploy. It did just deploy. It's
well,
up.
if you want the screen back, you can have it.
No, it's fine. It just says
okay.
deployed.
Yeah, amazing. Cool. Well, thank you, everybody, and we'll see you all in the future.
Bye.
Yeah, bye-bye.